In the not-so-distant future, humans are going to set foot on Mars. NASA believes we can get there by the end of the next decade, and if all goes well, we might even establish permanent colonies on the Red Planet by 2050. But there's one big problem that no one has been able to solve yet. It has to do with the most basic of concepts, standing up. Yeah, I know it sounds crazy. How hard can it be? Standing upright on an alien world, especially when we have some of the smartest minds working on this project. Well, harder than you might think. See, NASA scientists believe that our legs are not going to like the surface beneath them when they touch down on Mars. Now, I'm sure everyone's heard that Mars is a barren, red desert of a planet, but it's actually much more accurate to say that it's covered in a fine dust. In fact, 96% of the soil particles on Mars are smaller than the width of a human hair. For reference, that's about 30 times thinner than a strand of spaghetti. So what's the problem with that? What's difficult about landing on a bunch of dirt? Well, if you've ever played in a sandbox, you might have noticed that it's really hard to dig your feet into the ground and stand up again. You might have even gotten stuck in the process. This is because sand has almost zero cohesion. Each grain moves independently of its neighbors, and without the benefit of any outside forces, like wind or water, it's pretty much impossible to disturb the grains enough to make sand stick together. If you want to dig your feet into the ground, you have to disturb the layers deep enough to hit the bedrock underneath, which isn't always possible, and definitely won't be easy. The low gravity on Mars would make it a little easier to move around on the surface, but the atmosphere is so thin that the lack of air pressure could cause our blood to boil and our insides to explode. And the low atmospheric pressure, combined with the low temperatures, mean that any water we bring along is going to freeze solid in just a few hours. So there is no real easy way for us to melt away the snow and leave footprints in our wake. And the fact is that it's going to be incredibly difficult to keep from being buried in the first place. This is something that the folks at NASA's Jet Propulsion Laboratory, or JPL, already know all too well. After all, they're the ones who designed the Spirit rover, one of NASA's 3 Mars rovers, the other 2 being Opportunity and Curiosity. Both Spirit and Opportunity landed on Mars in 2004, with Spirit touching down in the Gusev crater. Its mission was to search for signs of water in the area, which scientists believed might also indicate signs of ancient life. Unfortunately, Spirit got a little too close to a sand dune and got stuck in a trap where the loose, powdery soil slid out from under its wheels. The rover tried to drive out of the situation but only succeeded in getting itself even more stuck. Eventually, the rover was completely buried up to its solar panels. Now, you're probably thinking, well, duh, robots don't get buried, right? They just drive over stuff. But the thing is, the more the rover struggled to free itself, the more soil it kicked up, and the more the soil packed around its wheels, making it impossible to free itself. As anyone who's ever been stuck in quicksand can tell you, it's surprisingly difficult to get yourself upright once you're down there. But that's just what JPL hoped to accomplish in their quest to save Spirit. When the engineers at JPL realized the rover had gotten itself into trouble, they began attempting to help it out. The first thing they did was increase the power of the rover's wheel motors in the hopes that it would be able to claw its way out of the hole. Then they tried rocking the vehicle back and forth, hoping to shift the weight distribution enough to free the wheels. And then they tried hammering the body of the rover with a nearby rock, which dislodged some of the soil around the stuck wheels. Finally, they were able to direct the rover's scoop towards the sky, so that it could clear some of the dust off its solar panels and get enough sunlight to charge its batteries. But the more the rover moved, the more it got stuck. And since the energy required to spin the wheels was drawing from the same battery that powered everything else, it wasn't long before the Spirit was completely drained. The last transmission JPL received from Spirit was on March 22, 2010. At that point, the rover had been stuck for nearly a year and its batteries were depleted. Even though it was far beyond its planned lifespan, NASA still considered Spirit a success. And I'm sure you'll agree that 1 year is quite a long time for a robot to live on another planet. But JPL didn't give up on trying to free the rover from its grave. For the next 3 years, they continued to try different methods of freeing the rover, like blasting the sand around it with sound waves generated by a device called a linear actuator. The theory was that by vibrating the sand at a particular frequency, they could break up the hard crust that had formed around the rover's wheels and allow the rover to start moving again. But this didn't work either. At this point, JPL started experimenting with drilling holes around the rover's wheels. The idea was that by removing some of the soil around the wheels, they might be able to give the rover some traction. But it soon became obvious that this wasn't going to work either. The auger that they used to drill the holes kept slipping in the loose soil. JPL even brought in a bulldozer to try and scrape away the surrounding soil, but even that didn't work. Eventually, JPL decided to give up on trying to move the rover altogether. On May 24, 2013, NASA announced that Spirit had been reclassified as a stationary research platform. Today, Spirit is still sitting on the surface of Mars, buried up to its axles in fine red dust. And while it might seem like just another story of human hubris and failure, there's actually a lot that JPL learned from Spirit's misadventure. See, Mars is covered in what's called regolith. That's just the fancy scientific term for loose dust and broken rock that covers the surface of the planet. And the stuff that makes up the majority of Mars' regolith is a mineral called jarosite. Jarosite is a hydrated magnesium silicate that's only found on Mars and the Moon, and it's also the mineral that caused Spirit to get stuck in the first place. You see, when the Spirit rover landed on Mars, it was greeted by a sea of fine grey dust. The rover's wheels churned up the dust and sent it flying through the air, coating the nearby landscape in a layer of fresh dust. And it was this dust that eventually buried the rover. As the rover continued to move, it kicked up more dust, which in turn caused it to get even more stuck. At one point, the rover was moving through an area that looked like flour on a bakery floor, except instead of flour, it was Mars dust. And as Spirit moved through this field of dust, it picked up speed, hitting a top speed of 1.2 kilometers per hour. That's about 4 miles per hour, which doesn't sound fast until you realize that the rover was carrying its entire weight on just 2 wheels. As you might imagine, the soil on Mars isn't very forgiving, and when Spirit hit a bump, it felt like running full speed into a brick wall. The impact jarred the rover violently, knocking the wheels off balance and sending even more dust into the air. All this dust made it harder and harder for the rover to see, but it kept moving until it reached a spot where the terrain was a little smoother. There, the rover slowed down, its wheels dug into the ground, and it came to a stop. Only then did Spirit realize that it was in trouble. Back at JPL, the engineers were watching Spirit's progress on their monitors, and they knew the rover was in trouble, but they couldn't figure out why. Spirit had made it through tougher terrain than this before, so why was it getting stuck now? To find out, they sent the rover's images back to Earth and put them in the hands of geologists, who quickly identified the source of Spirit's problems. It was the jarosite. You see, jarosite is unique among minerals in that it acts like glue when dry, but becomes slippery when wet. And since Mars is mostly made of iron, which rusts easily, the presence of even a small amount of moisture can make it extremely difficult to move around. In fact, the more jarosite there is, the more difficult it is to traverse the surface of Mars. And unfortunately, the part of Mars where Spirit landed happens to be one of the jarosite-rich meridiani, planum, which means that Spirit was never really in a safe place. Even if it had been able to drive away from its initial landing site, it would have eventually encountered another dust storm and gotten stuck somewhere else. This is a serious problem for any future missions to Mars, and JPL is still working to find a solution. One idea is to use a combination of pressurized wheels and spikes to cut through the regolith and provide traction. Another is to develop a type of rover that can move sideways instead of forward, which might make it easier to self-rescue if it does get stuck. And a third idea is to simply avoid the problem altogether by landing in a part of Mars that doesn't have as much jarosite in it. But this might not be possible since the parts of Mars with less jarosite are also the parts that are the most geologically active. That means that the risk of a dust storm is higher in those areas. So for now, JPL is still searching for a way to help us stand up on Mars, and the sooner they find it, the better. Because if we can't stand up on Mars, we'll never be able to explore it. And if we can't explore it, we'll never be able to colonize it. And if we can't colonize it, then all of this will have been for nothing. Thanks for watching this episode, which was brought to you by our amazing patrons. If you'd like to be one of those people, you can check out our support page,